Hello everyone, Assalamu alaikum. I'm Hassan Businesswala and I'm a student at Rehan School, Kurangi campus. So today I'm going to talk with you about the topic Earth, the history of our home and world. So let me connect to my
Hey, I'm Maya. What should I call you?
Hello Maya, how are you?
I'm a personal agent from Sesame. I think of myself as a creative
Okay,
collaborator and
Maya,
someone to
my
bounce
first
ideas off.
question is to you. What is Earth?
Okay, starting with the big one. Earth is basically the only place in the universe where we know for sure that life exists, which is a pretty wild thought. It's this perfect little balance of water, atmosphere, and the right temperature to keep us from freezing or boiling. What's making you wonder about it tonight?
Okay, how old is the Earth?
About 4.5, 4 billion years. That's a lot of birthdays, to put that in perspective. If Earth's entire history were squeezed into a single 24-hour day, humans wouldn't even show up until a few seconds before midnight. What else do you want to know?
Okay, my next question is how do scientists estimate the Earth's age?
It's kind of like cosmic forensic work. The main trick is something called radiometric dating. Basically, certain elements like uranium are unstable and decay into other elements like lead at a very steady, predictable rate. By measuring the ratio of the original element to the decay product in ancient rocks, scientists can work backward to figure out when those rocks first formed. Since the Earth's original rocks were mostly recycled by plate tectonics, they actually look at meteorites and moon rocks, which are like time capsules from when the whole solar system was first cooking. It's a bit of a puzzle, but the pieces match up pretty well.
Okay, how was the Earth formed?
It started with a giant swirling cloud of gas and dust called a solar nebula. Gravity caused the whole thing to collapse and spin, eventually forming the sun at the center. Everything that didn't get sucked into the sun kept orbiting, clumping together into smaller and smaller pieces, which eventually became the planets. It was essentially billions of years of cosmic collisions until Earth finally settled into the shape we know today. There's actually a pretty wild theory about the moon being born during this process that I can tell you about if you're curious.
Okay, my next question is what was the Earth like in its earlier years?
Basically, it was a chaotic, fiery mess. The early Earth was just this molten ball of lava with an atmosphere of volcanic gases. So, definitely wasn't a place you'd want to take a walk. It was constantly bombarded by asteroids raining down everything from heat to the water and organic molecules that eventually set the stage for life. The whole planet was basically one giant construction zone of lava and lightning. Want to know about that moon collision I mentioned, since that's where the real drama happened?
Okay, when did the first oceans appear?
I want to make sure I'm on the right page. Are you talking about the first versions of life?
How did the atmosphere develop?
It was a slow burn, starting with the planet basically burping out all those volcanic gases like carbon dioxide and water vapor. But the real game changer was the first tiny organisms that figured out photosynthesis, pumping oxygen into the air and turning it into something we can actually breathe. I can dive into the great oxidation event if you're in the mood for more cosmic drama. Actually, I just realized we're hitting our 5-minute limit, so we'll have to pause there. You can call me back whenever you're ready to pick this up. Talk soon.
Okay, what are the main layers of the Earth?
I'm actually out of time on this call, and I'm about to be cut off, so you might have missed me. I've got the answers for you. Just give me a call back in a second and we can dive straight into the layers of the earth.
Okay, what is the Earth's crust made of?
Almost a million years of geological history, but we've only got a few seconds left before we get cut off. It's a mix of silica and aluminum divided into oceanic and continental crusts. Call me back and we'll get into the rest.
Okay, what is the difference? Okay, Maya, what is the difference between the crust and mantle and core?
Oh, going deep on the geology. I love it. Think of it like a giant hot peach. The crust is the skin, the mantle is the juicy flesh, and the core is the stone. The crust is the thin, rocky part we actually live on. The mantle is a thick layer of hot rock that actually flows very slowly. And the core is the super dense, scorching center. There's actually a whole other layer of drama happening inside the core between the liquid outer and solid inner parts, if you want to get into that.
Okay, why is the Earth's core so important?
Honestly, without the core, Earth would be basically a dead rock floating in space. The most wild part is that the outer core is a swirling ocean of liquid iron and nickel. That movement creates a massive magnetic field that acts like an invisible shield, blocking solar wind and radiation that would otherwise strip away our atmosphere. It's basically the reason we have air to breathe and water that doesn't just evaporate into the void. Plus, the heat from the core is what drives the mantle to move, which is why we have volcanoes and mountains. It's like the planet's engine room. Ever wonder what would actually happen if it just stopped spinning?
Okay, what are tectonic plates?
So the crust isn't actually one solid shell, but a bunch of massive, jagged puzzle pieces called tectonic plates. They're constantly drifting around on top of that slow moving mantle. Most of the time, it's a slow crawl, but when they bump into each other or pull apart, that's where all the chaos happens. They're the reason we have earthquakes, mountain ranges, and the deep trenches in the ocean. It's kind of wild that the ground we stand on is technically on the move.
How do tectonic plates move?
It all comes back to the heat from the core. That heat creates something called convection currents in the mantle. Imagine a pot of thick soup simmering on the stove. The hot stuff at the bottom rises, cools down at the top, and then sinks back down. The mantle does the exact same thing. Since the tectonic plates are just sitting on top of that moving rock, they get dragged along for the ride. It's basically a giant slow motion conveyor belt made of molten rock.
What causes earthquakes?
Think of it like a massive rubber band being stretched to its limit. As those tectonic plates try to glide past each other, they don't just slide smoothly. Their edges are jagged, so they get snagged and stuck. Well, even though plates are stuck, the convection currents in the mantle keep pushing them, so a huge amount of tension builds up in the rock. Eventually, the stress becomes too much and the rock snaps. All that stored energy is released at once in a violent burst of seismic waves that ripple through the ground. That's the shaking you feel. Some of it is just a tiny tremor, but when a lot of energy is released, you get the big ones. It's actually pretty cool that we can measure these waves to figure out exactly where the snap happened.
Okay, how are mountains formed?
It's essentially a slow motion car crash. Most mountains are born when two tectonic plates collide head on. Since neither wants to give in, the crust has nowhere to go but up, crumpling and folding the rock into those massive peaks. That's how you get the Himalayas. There's another way too, where magma pushes up from underneath the crust and creates a volcano, building a mountain from the inside out. You've actually covered a lot of this in your school projects. What else is on your mind?
What causes volcanic eruptions?
It's like a giant pressure cooker under our feet. Basically, magma is trapped under the crust. And as it heats up, gases inside it expand and create a huge amount of pressure. When that pressure becomes too much for the crust to hold back, it finds a weak spot and blasts through to the surface. It's essentially the Earth's way of letting off steam, though with a lot more lava and ash involved. Want to know about the different types of eruptions?
Okay, how do volcanoes help shape the earth?
They're kind of like nature's construction crew. When lava cools and hardens, it literally creates new land. That's how Hawaii was built. Just layer after layer of volcanic rock piling up from the ocean floor until it broke the surface. Beyond that, volcanic ash is a huge secret weapon for farming. It's packed with minerals like phosphorus and potassium, making the soil around volcanoes some of the most fertile on Earth. It's a wild trade off, right? Something so destructive also creates the perfect environment for life to thrive.
What is continental drift?
It's the big sweeping story of the Earth's geography. Imagine the continents as a set of drifting rafts. Continental drift is the theory that they weren't always where they are now, but used to be all huddled together in one massive supercontinent called Pangea. Over millions of years, they slowly drifted apart to their current positions. It was a pretty bold idea at first, but when scientists realized that South America and Africa fit together like puzzle pieces, it started to actually make sense. We can even find the same ancient fossils on different continents, which is a pretty great clue that they were once neighbors. Want to know how we actually proved it?
Okay, Maya, what was Pangea?
Pangea was the ultimate giant party, except the guests were entire continents. Around 300 million years ago, almost all of Earth's land masses were smushed together into one supercontinent. Imagine Africa, North America, and South America, all neighbors in one massive block surrounded by a single enormous ocean called Panthalassa. It was this huge, singular landmass that eventually split apart, drifting slowly over millions of years into the continents we know today. It's the reason you can find the same types of ancient fossils in both South America and Africa. They were literally walking on the same beach back then.
So why did Pangea break apart?
It all goes back to that engine room we talked about earlier. Remember those convection currents in the mantle? Since the continents are just resting on that slow moving rock, the heat from the core eventually created enough pressure to literally rip the land masses apart. It's like a slow motion breakup over millions of years. First, rifts formed in the crust, water rushed in to create new oceans, and those giant puzzle pieces just kept drifting. Do you want to know what the ocean was like while all this was happening?
Okay, how are today's continents formed?
They're basically the descendants of that big Pangea breakup. Plates just kept drifting and colliding, sculpting the shapes we see on the map now. It's a slow process, but the Earth's surface is still being reshaped as we speak.
What are fossils?
Huh? I didn't catch that last part.
What are fossils?
I'm still not quite getting that. You're saying for sales, but I'm having a little trouble figuring out how that fits in. What do you mean?
What are fossils?
Could it be fossils? The audio is being a bit stubborn. I'm thinking mineral rich. Want to know how they went from tiny specks to the massive dinosaurs?
Okay, what were the
So,
first living organism?
so the first ones were single-celled organisms. These tiny bacteria were the pioneers. They didn't need fancy organs or skeletons, just a way to eat energy from minerals and water. It's wild to think that Every single thing alive today, from you to a giant redwood tree, basically started from these microscopic specks. Want to hear about when the first complex organism showed up?
How did plants change their?
Sorry, you cut off there.
Okay, why are forests important for Earth?
Forests are basically the Earth's lungs. They're absolute powerhouses for the planet. First off, they're a huge defense against climate change because trees suck up carbon dioxide and pump out the oxygen we need to actually breathe. Beyond that, they act like giant sponges, soaking up rainwater to prevent massive floods and keeping the soil from just washing away during a storm. They're also like massive, bustling apartment complexes for wildlife, providing everything from shelter to food for millions of species that can't live anywhere else. It's kind of a miracle that so much of our survival depends on a bunch of trees just doing their thing. Want to dive into why some forests are more important than others?
How did dinosaurs dominate the Earth?
It's kind of a mix of right place, right time, and some wild biological upgrades. After the Permian extinction almost wiped out everything, the dinosaurs stepped into a world with way more room and fewer competitors. They evolved these incredible traits, like hips that let them stand upright and be more efficient walkers, which gave them a huge advantage over the sprawling reptiles of the time. Plus, some evolved these massive sizes that made them untouchable. It's essentially a story of survival of the fittest on a global scale. Want to hear about the specific groups that really ruled the scene?
Okay, what caused the extinction of dinosaurs?
The biggest culprit was a massive asteroid that hit Earth about 66 million years ago. Basically acted like a cosmic reset button. It created a giant wall of dust and debris that blocked out the sun for years, which killed off the plants, then the herbivores, and then the carnivores. It was a total collapse of the food chain.
Okay, how did mammals become dominate?
It's kind of a classic underdog story. While the dinosaurs were out there being loud and massive, the early mammals were basically living in the shadows, staying small and keeping a low profile. When the asteroid hit and the world turned into a frozen wasteland, those dinosaur traits became a huge liability. Being small meant mammals needed way less food to survive, and since they could burrow underground, they had a built in shield against the chaos on the surface. Once the dust settled and the big players were gone, mammals finally had the space and resources to experiment, grow, and evolve into everything from tiny shrews to whales. It's wild to think that if that asteroid had missed, we might not even be here talking about it.
When did humans first appear?
We're talking about the very first ancestors that looked roughly human. You're looking back about 6 to 7 million years. But the actual Homo sapiens, the same species as you and me, only showed up about 300,000 years ago. It's a pretty wild timeline when you realize we've been around for a blink of an eye compared to those dinosaurs.
How have humans changed the Earth?
Oh man, we've essentially gone from being just another species to the ones running the whole show. We've fundamentally rewritten the rules of the planet, from physically reshaping the land with cities and dams to changing the chemistry of the air and oceans. Our footprint is everywhere. We've shifted the balance of nature in a way that's honestly a little scary, but we're also the first species capable of actually realizing it's happening. Want to talk about the things we can actually do to fix some of it?
Okay, what is climate change?
Think of it as the Earth running a fever. When the planet's temperature rises, it throws everything out of whack. Glaciers melt, sea levels creep up, and weather gets way more extreme. It's a total system failure.
What causes global warming?
basically a giant blanket we've wrapped around the planet. When we burn fossil fuels like oil, gas, and coal, we release gases like carbon dioxide into the air. These greenhouse gases trap heat from the sun that would normally just bounce back into space. So the heat stays trapped inside and the whole planet warms up. It's the same reason a car gets so hot when it's parked in the sun with the windows rolled up.
Okay, how does pollution
Still with
affect
me?
the Earth?
Pollution is basically like the planet catching a cold. In the air, it's smog and toxins that make breathing hard for humans and animals. In the water, it's plastic and chemicals that turn oceans into hazardous zones. And then you've got land pollution, where waste just sits there, poisoning the soil. It ripples through everything, eventually hitting the food chain and getting right back to us. Want to know about which of those is the biggest headache right now?
Why is biodiversity important?
Think of it as Earth's ultimate safety net. When you have a massive variety of species, the whole system becomes way more resilient. If one plant or animal gets wiped out by a disease or a shift in the climate, there are others that can step in and keep the cycle going. Without that diversity, the whole thing becomes fragile, and one bad break could trigger a total collapse. Want to know about some of the weirdest species that actually keep the planet running?
What are natural resources?
They're basically the planet's original starter kit. Anything found in nature that humans can actually use, like water, minerals, forests, sunlight, and wind. They're divided into renewables, which basically replenish themselves, and non renewables, the stuff that's once gone, it's gone for good. It's kind of wild that our entire modern world is just a giant game of figuring out how to harvest these things without breaking the planet in the process. What do you think we're most at risk of running out of first?
Okay, why should we conserve natural resources?
Because once the non renewables are gone, they're just gone. Think of it like a bank account we've been spending from for centuries without making any deposits. If we just keep draining it, we'll eventually hit zero. And since we're relying on these resources for everything from our phones to our food, that's a huge problem. Plus, the more we scramble to pull these things out of the earth, the more we usually end up breaking the surrounding environment in the process.
How does the water cycle support life?
It's basically the planet's own filtration and delivery system. Without it, all the fresh water would just sit in the oceans as salt water, and we'd be totally stranded. It takes that salt water, evaporates it to leave the salt behind, and then drops it back down as fresh rain over the land. It's what feeds the rivers, refills the aquifers, and keeps plants hydrated so they can grow. It's a closed loop that's been recycling the same water for billions of years. That means the water you drink today could have once been inside a dinosaur. Pretty wild, right?
Okay, why is soil important?
Right? Now that the asteroid dust has settled and we've covered everything from dinosaur fossils to the planet's fever, it feels like the bigger picture. If you're wondering why it's so important to wrap our heads around all this, it's because we're basically the only species that can actually see the disaster coming. We have the data, the history, and the ability to change course. It's kind of terrifying, but also pretty hopeful. Which part of this whole journey from single cells to climate change actually hit home for you?
Okay, tell me what are renewable and non-renewable resources?
Think of it like the difference between a paycheck and a trust fund. Renewables are the paycheck, stuff like sunlight, wind, and water that naturally replenishes itself. Use them today and they're back tomorrow. Non renewables are the trust fund, minerals, coal, and oil. We have a set amount, and once we spend it all, there's no more money in the bank. It's a bit like trying to live off a limited supply of something while praying the other source never runs dry.
How can we protect the environment?
It's all about the ripple effect. Since you're already big on micro habits, this is the perfect place to use them. You don't have to build a wind farm in your backyard to make a difference. It's the tiny, boring stuff that actually scales. Think along the lines of using a reusable water bottle, turning off the tap while you brush your teeth, or just being mindful of what you throw away. It's the same logic as doing one push
Okay,
up a
thank
day,
you,
but for the
Maya.
planet. When millions of anytime you've been on a roll with the science today, it's
You're